How can we use our immune system to kill cancer? In 1997, a new treatment was approved which used the body's own immune system to target a type of blood cancer. This treatment used antibodies, something our body naturally produces to fight off bacteria and viruses, and instead engineered them to target cancer cells, a concept known as immunotherapy. Now, this concept has revolutionized cancer care, but we still can't cure everyone. Some antibodies work amazingly well, while others fail, and I'm trying to work out why. But how do antibodies kill cells? Antibodies are Y-shaped proteins which recognize specific targets on the surface of cells. They bind to these targets using their two binding arms, the prongs of the Y, while the opposite tail end of the antibody acts as a flag to signal the immune system to come in and kill that cell. My project looks at three things that might impact how well that signal activates the immune system to try and understand why some treatments aren't working. The first factor I'm looking at is the binding strength of the antibody. Think of it like superglue versus blue tack. Superglue will hold something together forever, whereas the blue tack might fall off after a while. If your antibody falls off the cell before the immune system has seen it, how does the immune system know to kill that cell? But just how sticky does an antibody need to be? And is there such a thing as too much binding? I'm trying to find out. The next factor I'm looking at is the number of targets you have per cell. Now, it makes sense that 100,000 flags will activate the immune system better than 10,000. But is there a minimum number needed for effective cell killing? My early data suggests we need at least 80,000 targets per cell to effectively activate the immune system. So when we're designing future treatments, we should only choose targets of at least this level. And finally, targets can come in all shapes and sizes, and antibodies can bind to different places on their surface. This means the antibody might bind closer to or further away from the cell surface, or at different angles, either pointing straight up or lying sideways. These differences might impact how well the flag can be seen by the immune system, and so how well the treatment works. So far, it seems like antibodies that bind further away from the cell surface do better, which makes sense if you think about trying to see a flag from far away. It's easier to see at the top of a flagpole than it is at ground level. But I'm still looking into whether the angle of the antibody makes a difference. Overall, my research helps us to understand what factors impact how well an antibody can activate the immune system to try and understand why some treatments aren't working, so that we can design better treatments in future to more effectively kill cancer. Thank you for listening.